Our solar system feels like a familiar neighborhood, a place where the planets, moons, and asteroids follow predictable paths around our sun. For centuries, we've mapped its every corner, believing we understood the cosmic traffic that flows through our celestial backyard. But sometimes the universe surprises us in ways we never anticipated, sending us visitors from the vast, uncharted reaches of interstellar space. Every so often, an interstellar object, an uninvited guest from another star system, passes through, carrying secrets from far beyond our sun's influence. These rare travelers are messengers from the unknown, offering a glimpse into the distant corners of our galaxy. We've only confirmed two such objects before: Oumuamua in 2017, a mysterious cigar-shaped wanderer, and two I/Borisov in 2019, a comet with a tail of gas and dust. Each arrival sparked excitement and debate, challenging our understanding of what drifts between the stars. Then, in July 2025, astronomers around the world spotted a new arrival, 3I/Atlas. The discovery sent ripples through the scientific community as telescopes everywhere turned to track its path. Unlike anything we'd seen before, this object wasn't bound by our sun's gravity. It was just passing through, on a one-way journey, never to return. A true interstellar nomad. The odds of such an object visiting are astronomical, like tossing a single grain of sand from the shores of Cornwall and having it land perfectly on a postage stamp in Tokyo. The sheer improbability makes each encounter precious. These objects are time capsules, preserving the chemistry and history of their birthplaces. They carry the raw materials from ancient star systems, untouched for millions or even billions of years. But 3I/Atlas was different. Its properties weren't just unusual, but truly anomalous. Its composition, speed, and behavior defied our expectations, hinting at processes we'd never seen before. As the James Webb Space Telescope and other observatories studied it, the mysteries only deepened. Data poured in, but each answer seemed to raise new questions. This was no quiet visitor. It was a dramatic, puzzling guest, shouting secrets we struggled to interpret. Its activity was unlike any comet or asteroid we'd ever observed. The cosmic postcard had arrived, and its message was stranger than we could have imagined. It was as if the universe itself was sending us a riddle, daring us to solve it. Our understanding of the universe was about to be challenged in ways we never expected, as we faced the mysteries brought by this extraordinary visitor from the void. Most comets are small, icy bodies often no larger than a few kilometers across. They are remnants from the early solar system, composed of rock, dust, and frozen gases. Our first two interstellar visitors, Oumuamua and 2I/Borisov, fit that mold perfectly. They were relatively small and icy, just as we expected. But then came 3I/Atlas, shattering all our expectations. Its mass is estimated at a staggering 33 billion tons, making it thousands of times larger than Oumuamua or Borisov. Observations from the Hubble and Gemini South telescopes revealed a solid nucleus at least 5 kilometers wide. This was no ordinary comet, it was a true giant. Statistically, we should have found countless, smaller objects before discovering a behemoth like this. Its discovery was a statistical anomaly. The existence of 3I/Atlas challenges our current models of star system formation and ejection. It suggests that our understanding of these processes is incomplete. 3I/Atlas is also the fastest interstellar object ever recorded, moving at an incredible speed of 130,000 miles per hour. Such speed hints at a violent ejection from its home system, possibly due to gravitational interactions or even a stellar explosion. Despite furious outgassing, its path remains remarkably stable. Its immense mass gives it a significant amount of inertia, keeping it on course. This is no fragile snowball, but a celestial mountain plowing through space, defying our previous notions of what a comet could be. Its sheer size and speed have forced astronomers to rethink what interstellar objects can be, opening up new avenues of research and inquiry. The questions were piling up, and the journey of understanding this colossal interstellar visitor had just begun. An object's trajectory tells a story, revealing not just where it's been, but hinting at the forces and mysteries that have shaped its journey across the cosmos. And when we look at 3I/Atlas's path, we find something truly extraordinary. An interstellar visitor on a route unlike any we've seen before. Unlike most comets, which often swoop in at steep angles, 3I/Atlas's orbit is nearly aligned with the flat plane where all the major planets travel, an extremely rare occurrence that immediately caught astronomers' attention. This low inclination path allows it to embark on a kind of grand tour of the inner solar system, passing remarkably close to Venus, Mars, and Jupiter, almost as if it's following a carefully planned itinerary. On October 3, 2025, it will skim past Mars, offering a rare opportunity for close observation, if only we're able to catch it in time. Then, in March 2026, it will have a close encounter with Jupiter, the giant of our solar system, whose gravity could alter the comet's path forever. The sequence of planetary flybys seems almost too precise to be random, as if the comet is threading a cosmic needle, weaving its way through the solar system with uncanny accuracy. Most baffling of all, its closest approach to the Sun, when the comet is at its brightest and most active, will occur while Earth is hidden on the opposite side, making it completely invisible to our telescopes and instruments. The timing feels almost strategic, as if the comet's journey was designed to avoid our gaze at the very moment we'd want to study it most. Could this be coincidence? Perhaps. But such a perfect alignment of events is enough to make even the most skeptical scientists pause and wonder. The combination of its unusual path, the sequence of planetary encounters, and its perfect concealment from Earth raises eyebrows and stirs imaginations. The narrative unfolding here feels less like a random act of nature, and more like the result of deliberate design, an enigma written across the sky. Scientists are left wondering, are we witnessing a cosmic fluke, or is there something more intentional at play in the grand theater of our solar system? As 3I/Atlas neared the Sun, it began venting gas, typical comet behavior but with a twist. The James Webb Space Telescope found its coma was rich in carbon dioxide, 8 times more than water, an extreme ratio. This suggests it formed in a much colder environment than our comets. The outgassing is immense, creating a dense, green-glowing coma that hides the nucleus. But the real shock came from spectroscopic analysis. Astronomers detected nickel without any iron. In nature, nickel and iron are almost always found together. Pure nickel is rare and usually industrial on Earth. No known natural process explains this signature. The possibility arises. Could this be a sign of technology? The chemical fingerprint of 3I/Atlas deepens the mystery. The anomalies of 3I/Atlas have sparked fierce debate. Most scientists argue it's a natural if bizarre comet, evidence of the universe's diversity. If so, it forces us to rethink how planetary systems form and what they eject. But a few, like Avi Loeb, argue the artificial hypothesis must be considered. The mass, trajectory, planetary tour, and refined nickel all point to something extraordinary. Loeb suggests it could be a probe, its path and timing deliberately planned. Extraordinary claims require extraordinary evidence, but the debate is far from settled. Is 3I/Atlas a cosmic oddity or a message from another intelligence? The answer will come from data, not speculation. On October 3, 2025, NASA's Mars Reconnaissance Orbiter may capture high-resolution images as 3I/Atlas passes Mars. This could reveal surface features and clues to its true nature. After Perihelion, it will reappear in December, then fly by Jupiter in March 2026, possibly observed by NASA's Juno probe. Any detection of an artificial magnetic field would be groundbreaking. Earth-based observatories like the Vera Rubin Observatory will track its journey and help us prepare for future interstellar visitors. The ultimate test would be a spacecraft intercept, but that's a monumental challenge. Still, mission concepts are being discussed. Whether natural or artificial, 3I/Atlas is a compelling target for exploration. Its mysteries are shaping the future of interstellar science. Whatever its origin, 3I/Atlas has changed our view of the cosmos. If natural, it rewrites our understanding of planet formation and interstellar exchange. Our solar system is part of a vast, interconnected galactic ecosystem. But if it's artificial, the implications are profound. We may not be alone. It would transform science, philosophy, and our place in the universe. For now, 3I/Atlas remains a puzzle, a mirror for our hopes and fears. Are we seeing a cosmic fluke or a calling card from another intelligence? We can only watch, measure, and wonder. One thing is certain, our cosmic neighborhood is more mysterious than ever. The sky above us is alive with possibilities we're only beginning to grasp.